Good morning friends, welcome back to Panika Tutorials. In the last video, I have discussed how can we insert the nodes in the linked list. I hope you have watched that video. If you did not watch that video, I request you to go back and watch that video and come back to this video. In this video, I want to discuss how can we delete the nodes from the linked list. We will discuss the three scenarios. One is that deleting a node from the beginning, deleting a node from the end, deleting a node from a particular position. So I request everyone to watch the complete video for better understanding. Come to the scenario 1, deleting a node from the beginning. Let's assume that we have a linked list with 3 nodes. Now what is meant by deleting at the beginning means you need to delete the first node. This node you need to delete. How can we delete? We will discuss now. Is it clear? Now let me write a user defined function called delete at beginning. Okay, let me write BEZ. Now scenario 1, if you want to delete at the beginning, first you need to check whether nodes are there in the linked list or not. If there are no nodes in the linked list, we can say that linked list is empty. If linked list is empty, how can we delete the first node? That is not possible. So what is the condition to check the linked list is empty? If head is equal to null, then we can say that linked list is empty. So I will write if head is equal to null, then I can say that linked list is empty. If linked list is empty, how can I delete a node from the linked list? The next scenario is that only one node is there in the linked list. If one node is there on the linked list, suppose let's take that we have a one node in address location 100, then obviously this pointer will be null because this is the last node and this is the first node. So after this there is no node, so this pointer we will assign to null. So this is a null pointer which is not pointing to any address location. Then in this case head value will have the address called 100. In that scenario, if you delete this node from the beginning, then what we can say, the linked list is empty. Am I right or wrong? So let me discuss that scenario. Else if, how can I check only one node is there in the linked list? If head of next is equal to null, then I can say that only one node is there in the linked list. Otherwise, head of next will be some address other than the null. Am I right? In this scenario, if you see, we have more than one node. Head of next, what is head? 100. 100 of next is 200, which is not equal to null. So head of next is equal to null, then I can say that only one node is there. If only one node is there, if you delete that one, is it clear? Then what should be the null head value? Head value should be null, because if I delete this one, the linked list is empty. If the linked list is empty, you should say that head is equal to null. Okay, before do that one, you have to delete this one. Am I right or wrong? So how can we do it? This is pointing with the help of head. Okay, you can display like this, printf. The deleted node is %d. You can write head of data. So that element we are deleting. I hope it is clear for you. Is it clear? Are you able to understand? Head of data, which is 10. 10 value will be displayed. That node where the value is 10 will just deleted. Okay. If you don't want to write, you can avoid this one also. Now what should I do? I have to release this memory. How can I release the memory which is allocated during the runtime? With the help of a function called free. Now this function, you have to give the name of the pointer which is pointing to this memory location. What is the pointer which is pointing to this location? Head. So you will write free of head. Okay, then you have to make head is equal to null, because it is your duty. See, once you release this memory, what will happen? This in 100 address location, no memory is there. So if you write 100 here, then it is a dangling pointer problem, because a pointer called head is pointing to an unexisting memory location. So it is your duty to make as a null pointer. So how can you make a pointer as a null pointer? If you assign the value null, then it will become a null pointer. Okay, let me close the else if these two scenarios does not match, meaning is that linked list is not empty, only single node is there. Let's take this scenario. In this scenario, the linked list is not empty, it has more than one node in the linked list. Now look at this scenario. How can we handle it? We will declare another pointer of strut node type. Strut node temp is equal to head. I will assign whatever the value is there in the head to the temp. Now this temp also pointing to the first node, because if I have to release this memory, some pointer should be pointing here. Okay, are you able to understand? So now if I delete this node, what the head should point? Head should point to this one. Am I right? So how can I get address of this one? Address of this one, I can get it as temp of next. So what you can write is that head is equal to temp of next. What is temp of next consists of? This is temp 100, 100 of next is 200, that you are assigning to the head. So now head will become 200, so it is pointing to the second node. Now temp is pointing this one, you need to release this memory. How can you release that memory? You can write free of temp. Okay, so the memory will be released, and you have to make it as a null pointer. It is your duty as a programmer. If you want to be a good programmer, you should avoid the dangling pointer problem. You should make that pointer as a null pointer. Okay, so else. Is it clear? Are you able to understand it or not? So we have declared a variable called temp, and we have assigned the address which is there in the head. Then head is equal to temp of next. So now head is pointing to the second one. Then we have released this memory free of temp. Then temp is equal to null. So now this becomes a null pointer, and this one has been successfully deleted. Is it clear? Else is closed and deleted beginning is closed. So this is the user defined function to delete a node from the beginning in a single linked list. I hope it is clear for you. Let me discuss the next scenario, deletion at the end. Okay, you want to delete a node from the end. Okay, is it clear? To make you understand, let me take an example. Let's take that we have 3 nodes, okay, or let me take 4 nodes. We have some 1 in address location 100, 2, some 200 will be there here. Let's take that here 150. So this is 100, this is 150, and this is head having 100. Okay, is it clear? Are you able to understand? So we have 4 nodes. Now I want to delete a node at the ending. Ending means this node I want to delete it. If I want to delete this node, look at here what I have to do. Here I have to make the null. Am I right? If I make, see what you can say, sir, you traverse up to this node. Is it? Some people will say from starting you traverse up to this node, and this node you write. Suppose it is pointing with the help of a pointer called temp. You can write temp of next is equal to null. They will say that this link will be deleted. Then how can I release this memory? I have to release this memory also. If the link has been down, then this node address I will not find. If this node address if I cannot find, how can I release this memory? That is not possible. So using single pointer we cannot delete a node from the end. So we need two pointers. One pointer will be pointing here, another pointing will be pointing to this node. Then we can easily do. So let's take that we have two nodes. One is, let's take that this is previous node. We have two pointers, previous node and temp. Okay, then if I have like this, what I can do, previous node of next, I can make it as null. Then here I will get the null, so this link will be down. Then I can write free of temp, and temp is equal to null. That's all. Is it clear? So we need two pointers pointing to the last but one node and last node respectively. So to do that one, see here I will not discuss those two scenarios. One is that the linked list is empty and only one node is there. Are you able to understand? If one node is there, then you have to make head is equal to null and you have to free the memory. Is it clear? Those two scenarios I will not discuss. Let's assume that we have more than one node in the linked list. So what I need to do is that I need to declare the two pointers of strut node type. Okay, one is temp and another one is previous. I need to assign temp is equal to head. Okay, now I need to traverse up to temp of next not equal to null. Temp of next not equal to null means, look at here, I will write this code for you. While temp of next not equal to null, okay, then what you need to do is that you have to write previous is equal to temp. Okay, temp is equal to temp of next. Let me complete this one and then I will explain what will happen. Look at here, we have taken two pointers. One is the temp and another one is previous. Is it clear? Are you able to understand it or not? I have assigned temp is equal to head. So what is the address is there in head 100. So even temp is also having the address called 100, so which is pointing to the first node. Now while temp of next not equal to null, temp of next 100 next is 150, which is not equal to null, then this condition is true. If this condition is true, what are the two statements are there in the while should be executed. What is the first statement? Previous is equal to temp. So previous also will get addresses 100 and then temp is equal to temp of next. Temp of next is 150 that you need to assign to the temp. Is it clear? Are you able to understand? Now look at again the condition. While temp of next not equal to null, 150 next is 200 which is not equal to null. Again this condition is true. So previous is equal to temp. Now you will get 150 here. Temp is equal to temp of next. 150 next is 200 that should be assigned to the temp. Is it clear? Are you able to understand? Now temp is pointing to this node, previous is pointing to this node. Again look at the condition. Temp of next 200 next is 300 which is not equal to null. Then previous is equal to temp. So you will get 200 value here which is an address. Temp is equal to temp of next. 200 next is 300. You will get 300 here. Now look at here. Temp of next not equal to null. 300 next is null. So null is equal to null, but they are saying null not equal to null. So this condition is failed. If this condition is failed, it will come out from the while loop. By once this comes while loop, look at what is the previous is pointing and temp is pointing. Previous is pointing to this node and temp is pointing to this node. Is it clear for you or not? So we are in this position and in this position. Now what should I do? Is it clear? So now what I have to do? First thing is that I have to make here it as null. So what is the statement I will write? Previous of next is equal to null. If I do it, here null will come. Is it clear? So this link has been broken because this node pointer is become a null pointer, so it is not pointing to any memory location. Now I have to release this memory with the help of what? With the help of a function called free, okay, temp. because this node is pointing by a pointer called temp. Okay, then you have to make temp is equal to null. You have to make it as a null pointer, otherwise you will get a dangling pointer problem. Okay, let me close the function. That's all. Is it clear? Now this one you have released and you have made it as a null. That's all, simple. Is it clear? So we have done with the two scenarios. One is the deleting a node from the beginning and from the end. Now I want to delete a node from the particular position. Let me erase this one so that I can use this space to explain the next scenario. Let me take a linked list and discuss the solution for you. I hope you are enjoying my lecture. If you like it, please press the like button, share the videos with your friends. Okay. Now let me take some nodes in the linked list. 1, 2, 3, 4 nodes I am taking. 100, 200, 150, 300. Is it clear? Don't think that always the address will be in the increasing order. It will be random. Is it clear? So that's why I have written like this. 10, 20, 30, 40 are the values, and the address will be 200 here, 150 will be here, 300 will be, and here it will be null. Is it clear? So you have a links like this, and head is pointing to the first node in the linked list. Now what is meant by deleting at a particular position? Let's take that user has entered the position as 2. Then you need to delete this node. Is it clear? If you want to delete this node, what are the things you have to do? First you have to make this node next is equal to this node address. Am I right? See, one thing is that you have to release this one, is meaning is that first you have to make this node address should be this node address. Is it clear? Here 150 should come. Then this node will be pointing to this one. Then here you should make null. Then you have to release this memory. Then whatever the pointer which is pointing, you should make it as a null pointer. These are the things you have to do. So to do that one, what you need one pointer at this node and one pointer at this node. So one pointer here, what will happen? Temp of next is equal to, suppose this pointer is there, let's take that it is temp of next is equal to here whatever the address is there, that you will write it. Is it clear? So we need 2 pointers to perform this task. So let me write the user defined function called delete at a particular position. Okay, are you able to understand? So first what I will do is that I will declare 2 variables called POS and I will make it as initialize I is equal to 1. Okay, so I will ask the user to enter the position. Printf enter the position okay. Once the user has entered the position, it is our duty to read it with the help of a function called scanf. Scanf %d ampersand POS. Then in the last lecture, when inserting at after a particular position, I have discussed about a function called length, which is a user defined function. You please refer that lecture. Okay, I will write int count is equal to length. This function we have already discussed to count the number of nodes in the linked list. Suppose let's take that in the number of nodes in the linked list is 4. Then whatever the position you are giving should not be more than 4. Is it clear? Suppose let's take that in this linked list only 4 nodes are there. If user has entered the position as 5, is it valid? It is not valid. Is it clear? So what you can write is that if position is greater than count, then what you should display? You should display as invalid position. Okay, else only if this is not, what should be happen? Okay, now what you have to do is that you need to declare two pointers of strut node type. So one is that previous and another one is temp. You can assign temp is equal to head. Is it clear? Are you able to understand it or not? Now what I will do is that while I less than position -1, that is important because you no need to traverse up to that node. While I less than position -1, okay, temp is equal to temp of next, okay, I plus plus. What will happen, I will discuss for you with an example. Let's take that user has entered the position as 3. Just consider that position is equal to 3. So in a variable called POS, you have the value called 3. Is it clear? Now I is equal to 1. That is what we have initialized. Now let's check it. Else this condition is failed because this length will be 4. So position is less than the count value, so we can say that this condition is failed, so it will come to the else block. You have declared two variables called previous and temp. You made temp is equal to head, which is 100. Now look at here, I less than position -1. What is the I value? 1 less than position -1, which is 3 minus 1, 2. 1 is less than 2. Yes, this condition is true. If this condition is true, you need to execute these two statements which are there in the while loop. One is temp is equal to temp of next. Temp of next is what? 200. 200 you should assign here. Then I plus plus. Now I value will become 2. Is it clear? Are you able to understand it or not? Then look at the next one. Once it is done, you are checking this condition. I less than position -1. I value is what? 2. So 2 is less than 2. No, condition is failed. If this condition is failed, you will come out from the while loop. Is it clear? Now look at where is temp is pointing. Temp is pointing to this node. Is it clear? Are you able to understand? Now what you will write is that you will write previous is equal to some pointer I have taken. Previous is equal to temp of next. You will write this one. Previous is equal to temp of next. What is temp of next? Temp is pointing this one. Temp of next is 150. 200. Next is 150. So previous is having 150. So now previous is pointing to this node and temp is pointing to this node. Is it clear? Now you want to delete this one. This node you have to delete. That is what? Delete at a particular position. The node which is at the position 3, you have to delete it. So what are the step 1 you have to do? You have to write here temp of next is equal to what address should be there here? 300 should come here. How you will get 300? Temp of next is equal to previous of next, you can write. So let me write here. Let me make it like this so I can use this space. Okay. Temp of next is equal to previous of next. I hope it is visible for you. Okay, otherwise let me write here so that it will be clear for you. Okay, after this one I will write temp of next is equal to previous of next. What is previous? Previous is this one. Previous of next is 300. So which is you are assigning to temp of next. So here you are assigning 300. So you have a link from this node to this node. Is it clear? Are you able to understand? So this link has been deleted. Okay. Now what you have to make? Previous of next is equal to null. You should write previous of next is equal to null. If you do it, here you will get null value. then this link has been down. Is it clear? Then what you have to do? You have to release this memory. How can you release this memory? You have to write free and you have to give the pointer name. So whatever is the pointer which is pointing to this node previous. So we have given free previous. Okay. Is it clear? Then what you have to make? Previous is equal to null. You should make this one as a null pointer. Okay. Then done. This node will be deleted. From this node to this node, the link will be there. Okay. And you made it to null pointer. So let me close the else. Let me close the function. So I hope you have understood how I have deleted a node from a particular position. So whatever the concepts I have discussed in this video, I hope it is clear for you. If you still have any doubts related to any concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.